sir.
Yes, sir.
Yes, sir.
Good morning, Dr. Firdaus.
Good morning, ma'am. So, are you ready for the session?
I can't hear you.
Yes, sir.
So, everyone is, hearing me well.
Yes. I can hear you now.
Okay. So, all participants, hope you are doing well. So, in case you are having any issues, kindly reach us on WhatsApp. So, before starting today's session, as I have already, announced to the guidelines that we are not taking any feedback from you because Zoom is doing that work for us. So Zoom is giving us the frequency at what time you have joined, how many minutes you have been, there. So don't worry about the attendance. We are having that with us. So 90% participants who will attend all the sessions, they will be, issued the certificate. So our mission and motive to organize such workshops is only to empower you so that you learn, research, and try to elevate in the world of research, which is day by day becoming challenged because AI and machinery is coming. So therefore we need to be more focused to update our research skills. So without taking much time of you, I would call Ms. Shivangi to start the session, and while ending the session kindly take the group photo. So that let me take one of us so that we can share later on the social media. So
Okay.
over to you, please go ahead.
Thank you, sir. And welcome, STEAM patron, keynote speaker, moderators, and all the participants to the 10 days online workshop on research analytics for the social sciences. This workshop is organized by the Vivekananda Global University, Jaipur, and Jindal Center for Global South in collaboration with the Jammu and Kashmir Economic Association and the Cafe Economics. The objective of this workshop is to provide a comprehensive understanding of the research process, blending theoretical concept with practical hands-on sessions. Participants here will explore research analytics from conceptualization to empirical execution using advanced statistical and economic methods. The program also includes training on tools like Gretel and eViews and introduces emerging topics in big data and AI. Moving on further, ladies and gentlemen, we are delighted to welcome Dr. Silky Vigg Kushwah as a distinguished speaker for our 10-day workshop. A recipient of 2 funded major research projects under the IMPRESS scheme by the Ministry of Human Resource Development and AICTE, Dr. Kushwah currently serves as a professor in the Department of Finance at the New Delhi Institute of Management, NDIM. She's also a visiting faculty member at NMIMS Global Access School for Continuing Education and an adjunct faculty member with Upgrad Education Company. Dr. Kushwah is the co-editor of the UGC-approved Journal Review of Professional Management published by Sage Spectrum and is pursuing her postdoctoral studies at Amity University, Dubai. With a PhD in management from Jivaji University and expertise in financial analytics, corporate finance, and econometrics, she brings over 20 years of academic and research experience. Having authored more than 70 research papers and presented at 50 plus international conferences, Dr. Kushwah's global perspective and expertise in conducting workshop and development programs make her an invaluable addition to this event. We warmly welcome Dr. Silky and look forward to her insightful session during the workshop. Before that, dear participant, to ensure a smooth and distraction-free session, please keep your microphones muted during the presentation. After the speaker has completed their presentation, there will be a dedicated Q&A session where everyone will have the opportunity to ask their questions. Thank you for your cooperation. Over to you, ma'am.
Thank you, Shivangi, for such a soft introduction. Shivangi, I want to share my screen. May I?
Yes, ma'am.
Okay. So I'm not the host right now. I'll just check once again. Yeah, now I can share. I'll just do it full screen first. Visible?
Yes, ma'am, it's visible.
Okay, thank you so much, Shivangi. Let's start the session. So my session, which was asked by Dr. Firdaus, thanks for the opportunity to take this session at this wonderful platform here. So the session was on regression analysis. That's a multivariate analysis. And the software that I have picked up today for you people is eViews. I was seeing in your brochure that eViews has already been installed by you people. So it will be, it makes my task easier. So let's start with it. Shivangi, one more thing. Can you see my pen moving here? Is my pen visible here, Shivangi?
Yes, it is.
Okay, thank you, Firdaus. Thank you. Okay, let's start with the session. So the things that we'll cover here today is the correlation versus causation analysis. So what I've seen yesterday is that you people have done correlation. So we'll discuss the difference between correlation and causation here. Then we'll talk about the regression analysis. What is regression analysis? What are the assumptions that we have to check before applying the regression model? And we'll also apply the model on eViews, and we'll also try to do the residual diagnostic of regression if time permits. Then we have a short poll for you people so that we get the understanding that how much you people have understood through this session. So let's talk about correlation versus causation. So when we talk about correlation, we say that two or more variables are considered to be related. They are related in a statistical way. How do you call them related? Because their value changes statistically. So we say if one variable moves up and the other variables move up and down simultaneously, then we say that the two things are correlated. I'll give you a very simple example. Like if I talk about stock market and if I talk about foreign institutional investments. So if I want to say that, stock market of India Nifty with the index Nifty 50, it moves down when the FIIs, take out money from the stock market. So I say that the two variables, FIIs and the stock index Nifty 50, they are correlated with each other. So, correlation is a statistical measure that describes the size, how much they are correlated. Let's say two things are 100% correlated. That means the correlation will be +1. Why? Because if one moves, let's say upwards, the other also moves upwards. So the direction is also clear that it's a positive correlation. If it's a negative correlation, you people have already studied yesterday, then if one moves up, the other moves down. So this is correlation. But the question that comes to our mind is a correlation between two variables does not automatically mean that the change in one variable is caused by the change in the other variable. Here is, the place where regression comes into picture. If one thing is moving up and the other thing is also moving up at the same time, we'll say that they are correlated to a certain extent, maybe 30%, 40%. So correlation may be 0.3, 0.4, or a higher correlation if they, move, very much together. We say, the correlation is quite high, it is 0.8 or 0.9. That's fine. But the question is that if the two things are correlated, does it mean that one thing is causing the other thing and vice versa? So that is where causation comes into picture. So causation is different from correlation, where two things can be correlated with each other, But it is not at all necessary that one thing is causing the other thing to move. Causation clears the picture. Causation says that if one event is the result of the occurrence of the other event, if one event is the result of the occurrence of other event, there is a causal relationship between the two events. There will be correlation plus causation also. So the two things move together. This is also referred to as cause and effect relationship that we study. Cause and effect relationship as we study. So, theoretically, the difference between the two types of relationships are easy to identify. Let's check how we can identify that. I give you a very simple real life example. If I tell you, that smoking causes an increase in the risk of lung cancer. You smoke more, you're a chain smoker, it increases the risk to develop lung cancer. So one of the reasons for lung cancer is the person might be a smoker. So smoking causes lung cancer. So there is a causal relationship between the two. But if I say whenever in parties you see, smoking, you also, sometimes smoking is accompanied with alcoholism. People when they use alcohol, some of them also smoke at the same time if they are smokers. So in such a case, I say that smoking is correlated with alcoholism, but it does not cause alcoholism. If somebody is a smoker, it will not lead to somebody start with drinking. Okay. But if somebody is a smoker, it may cause, increase the risk of lung cancer. So here in the first example, it is causation. And here in the second example, it is correlation. Okay, I'll give you another example. This is, a real example of my life. I had a student and a very bright student, Sayatan. He's placed in Deloitte now. Now, he told me, ma'am, and I used to teach him financial analytics. So he told me, ma'am, fortunately, it's raining right now. And whenever it rains, my marks are really good. So, we both laughed together. So it was his midterm going on. He said, ma'am, today, I have given a very good paper. It's raining, and I feel, he has this, misconception in his mind that if it rains, then, his mood is good and he really does well. So I asked Setan that, Setan, tell me, is it causation or correlation? Because we were studying this thing at that time. So whenever it rains, can be correlated, okay, but cannot be the cause of Satan's A grade. So, you can correlate Satan's A grade with rain. It can be correlated somehow because he had a couple of past events that said that whenever it rains, Satan gets a good result. But there is no cause and effect relationship between that. Does not make sense. Cause and effect relationship can be maybe Satan works hard, maybe Satan is intelligent, maybe Satan has a good faculty, maybe Satan cheats. Out of these four could lead to an A grade, but rain does not lead to A grade. Can be correlated. So it might be when there is an increase in rain, there is an increase in marks of Satan. But they two are not having causal relationship between each other. This we need to focus in research with our variables. Last example that I take, let's say there, in a couple of months we'll have very hot and sunny weather in India, in Delhi especially. So, if I say that whenever it's very hot, whenever the weather changes to, summers and it's a very sunny day, the sale of ice cream increases. There's an increase in the sale of ice cream. The other thing which we see that, okay, whenever the summers come and the sunny weather is there, it's very hot temperature, then the sunburns also increases. There's an increase in sunburn. So if I calculate the correlation between the sale of ice cream and the number of people getting sunburn, they will be correlated, especially during summer season. They will be correlated. There will be a high correlation between the two, between the sale of ice cream and the number of people having sunburn. But can I say that sunburn causes ice cream sale or ice cream sale causes sunburn. No, that is not the truth. But I can say there is a causal relationship between the summer season and ice cream sale, the summer season and sun. So this is cause and effect relationship between summer weather and ice cream sale, but a correlation, a typical correlation and no causal relationship between sunburn and ice cream sale. So I hope the difference between correlation and causation are clear. In future, we cannot say that two things were highly correlated, so one thing has caused the other. No, it's not necessary. For that, you need to check regression between the two variables. Let me check, there are some messages. Okay. Perfect. Let's move ahead then. Why are correlation and causation important? See, both are important. Let's take a couple of examples. Is pet ownership associated with living longer? People say, the people who keep pets, they live longer, they live happier, they do not have depression. So studies goes on. Studies go like this, to check the relationship. Did a company marketing campaign increase their product sale? So again, there are two variables: the market campaign and product sale. Relationship between oil price and stock returns of oil company. Let's say the oil price, keeps on increasing. What is the impact on the stock price return of such oil companies? So these are some of the studies that people have conducted earlier, and these studies require both correlation and causation. Why? Once you understand that, so they say that before you apply regression, you should always check correlation. You should always check correlation to identify whether the dependent and independent variable have some relation with each other, and then you check what is the cause and effect relationship, how much is the effect of one variable on the other. So by understanding correlation and causality, it allows our policies and programs that aim to bring out some desired outcome. So once you apply the regression model, you will be able to understand, does the particular company needs to focus on the market campaign, need to spend money on the market campaign? Is it really resulting in increasing the product sale, or there are some other factors or some other independent variables that are impacting the product sales? So it certainly leads to policy making and decision making. That's why such studies go on. Let's come to regression analysis. Now, what is regression analysis? It's called a predictive modeling technique. Why a predictive modeling technique? Because you can do the forecasting. Once you find out the relationship between so there are a couple of variables. I hope you people are already well aware of that. There is a dependent variable. There are independent variables. So you try to predict the dependent variables by seeing the movement in the independent variable. Dependent variable को पता करने के लिए कि क्या उसकी value होगी, you try to change the values of different independent variables to understand what is the impact on the dependent variable. Okay. For example, you increase the incentives of employees in a college. You increase incentives, by giving them, cash incentive. If they get their paper published in, let's say A star, AQ1, Q2, you increase their number of trainings, okay, given during a year. You give them, more of, holidays, all national level holidays and state level holidays. And then you see what is the impact of such, independent variables on the employee performance. Has it increased? Is his feedback increased? And other things. Okay. So regression analysis is a form of predictive modeling technique which investigates the relationship between dependent variable and the independent variables. Can be one, can be many, which are called predictors. This technique is used for forecasting, as I told you just now. It's used for forecasting, especially in finance, guys. We use this technique for forecasting, the future movement of exchange rates, the future movement of stock prices, the future movement of oil prices. Okay, how will the interest rate move? How will the GDP move? And finding the cause and effect relationship between the variables. What are the different factors or different, out of those factors, the main variables, and those are independent variables that impact the dependent variable. Right now, the most commonly used modeling technique is linear regression. So basically, we say there are two types of linear regression. One is the simple linear regression. One is this is also called single linear regression. One is the multiple linear regression. So two types of regression. Simple. So simple means there is one dependent variable and one independent variable. And multiple linear regression, which is a broad linear regression model, which says one dependent variable and multiple many independent variables. So this is more used in research institutes, in consultancies, in institutes, so that you can have a broader understanding of all the variables that are having an impact on the dependent variable. Now it is represented by this equation. I know you people are well aware of this equation, but it will take me hardly 1 minute to describe it. This y is your dependent variable. This x is your independent variable. And these are the coefficient of x, okay? And this alpha, which is also known as constant sometimes, and this error term. These are two important things that we cannot skip. Why? Alpha indicates that, let's say you are studying two things, you are trying to see the impact of advertisement expenditure on the sales, of a product. Okay. In such a scenario, they say that this is your independent variable and this is your dependent variable, sales of the product. Now, what is alpha? Let's say that this beta comes out to be 0. This coefficient of x, which is called beta, comes out to be 0. That means there 0 into x, that means there's no impact of advertisement on the sales of that particular product that we have taken into consideration. But there is some alpha. Alpha means, the capacity of the dependent variable to move itself because of its own properties. So yes, we say that there can be many independent variables, like advertisement expenditure, the variety of products, the stores where the product is kept, and multiple other things, the innovation in the product. So x1, x2, x3, we can have multiple equations, like the equation will be something like y equals to alpha plus beta 1 x1 plus beta 2 x2 plus beta 3 x3, so on and on, plus error term. So what does it mean? If this is the sales of a particular product, let's say this is, the advertisement expenditure, and this is the innovation in the product. This is the type of product. Next is pricing. Okay. Fifth is the shops where it is, kept. So there can be multiple independent variables. Still, एक वेरिएबल की खुद की क्षमता, उसकी वैल्यू लाने की, कि अगर सब कुछ को हम निल कर दे तो उसकी खुद की भी एक क्षमता है कि वो एक वेरिएबल को खुद को मूव कर सके. दैट इज नोन एज द कांस्टेंट टर्म. दैट इज नोन एज अल्फा हियर. Its own, its own capacity to move its value. Okay, if all these things are 0, then also there is some value of y. It is because of its own capacity. It's because of the alpha term. Then the other important thing, guys, that we need to know. Just a second, I'll try to erase this. Then, error term. We talk about the error term. We have taken all the independent variables. Let's say for knowing the impact of various variables on the sales of a particular product. Let's say the sales of a perfume. I took couple of variables. Okay, I took couple of variables just now on the sales of some perfume. And I took couple of independent variable x1, x2, x3, and x4, and there was an alpha term, of course, to it. And then there's an error term. Error term says that if all these variables in real life cannot explain 100% change in the sales of perfume. I repeat once again, all these independent variables like advertisement expenses bhi aap kar rahe hain. You are also producing different types of perfumes. You're putting them in all kind of shops like big bazaar, shopper stops. The number of shops are also many, and there are other factors also. You you are also giving some schemes on perfume. Still 100% change in the sale of perfume cannot be explained by all these variables along with alpha. That means the researcher has left some of the variables which also result in the movement of this but not taken in the study. Those variables come in error term, which is also known as residual. This is also known as E term, is also known as residual. In finance, we also call it sometimes white noise. Why residual? That means, let's say, we'll look at it deeply further, but there is a term called R square. R square basically tells, that let's say your R square is 90%. So you say that 90% change in the sales of perfume is caused by all four variables. What about the 10% change? It is not defined here. That means that 10% change is done by some other variables which the researcher has missed out. And those things come under error term. Those things come under error term. Okay. When we, somebody has written if the beta value is this, how can we interpret? We'll do this once, we see the results of the regression on e-views. Okay, right now I am explaining the equation. If there's any doubt in the equation, please let me know. Otherwise, I move ahead. I hope somebody asked me, ma'am, what does error term means? I hope it's clear. Let's move ahead then. So where alpha is the intercept, B is the slope line, and E is the error term. This equation can be used to predict the value of the target variable based on the given predictor variables. Okay. For your simplicity, I'll clear the doubt. Somebody asked that, if this beta is 0.83, you basically check, my dear friends, that let's say the equation comes out to be y equals to, you get some alpha, let's say alpha is 6.2 plus beta is 0.83, somebody told me, and they are assuming it, of course, and this is your independent variable x plus the error term. You put the error value also. So let's say 1 unit of, you want to check that if there is a change in 1 unit of x, how much change it causes in y. So you just multiply it with 1, add all these things, and you get the value of y. And then you can say that, it's like a simple linear. If you remember, guys, we have done it in school days, linear equations. So you get the value, you have this equation 6.2 plus 0.83 x plus error term. You just put value of x, whatever, the decision maker is asking you to put. Let's say the decision maker is saying that, okay, we have, 10 units of x. What will be the movement in y? Okay, so you change, instead of 1, you multiply it with 10, and then you check what is the change in the y. This is the way you do the interpretation. I hope the doubt is clear. Somebody asked this doubt. I think it was Gohar. Okay, thanks. Vidhu will do R square. I was just explaining R square to explain the error term. We'll do it in detail. Okay. Now the difference between the simple, the difference between the simple linear and the multiple linear regression is that multiple linear regression has more than one independent variable. I already told you this thing in the previous slide. Now, a note about the sample size. This is a thumb rule that we use, but it's not like कि Dr. Silky कह रही है तो यही rule होगा. But this is a thumb rule that we use that regression analysis requires at least 20 cases per independent variable. Let's say in a study where I'm studying, let's say the impact on oil prices, okay, of many macroeconomic variables. Okay, so oil prices, movement of oil prices, I'm picking up, let's say, inflation, I'm picking up exchange rates, I'm picking up, let's say, FDI movement, and I'm picking up, let's say, the stock price movement, Nifty 50, and I'm checking the impact of these variables on oil prices. Just for an example. Okay, in this case, let's say I've picked up these four. So I have 4 variables. So 4 independent variables into 20. That means my observations should be 80 minimum. For each variable, let's say for inflation, I should have 80 observation, 1, 2, let's say I am taking the quarterly data from 2025 and I'm going, backwards. So I need to have 20 quarters of data values here for inflation, for exchange rates, for FDI. Why? Because, what I follow the thumb rule, which I have seen in multiple research papers, that per independent variable, there should be 20 cases. So this is what it means. Now let's talk about the assumptions of regression model. And let me tell you, after teaching for 20 years in management, I've seen that, students during their summer internship, winter internship, when they, or, their major research project, when they apply regression on, the topic that they pick up between the dependent and independent variable, they never check the assumptions of regression model, which is very, very necessary. Otherwise, we cannot, the assumptions are not fulfilled, and especially some of them we cannot apply regression model. Even if we apply regression model, software तो आपको output लाके देगा ही. You just put the input, software will give you the output, but your model won't be a robust model. You cannot make policy implications out of that. You cannot, generalize the results out of that because you haven't checked the assumptions. So a couple of assumptions I have taken. No hidden or missing variables, linear relationship, no autocorrelation or serial correlation, no multicollarity, no yes to homoscedasticity, no to heteroscedasticity, residual, norm. The residual should be normal. The number of observations must be greater than the number of X. Linear regression is very sensitive to outliers. Let's check them one by one. Okay. So no hidden or missing variables. It means you cannot leave the predictors, important predictors, which are also known as independent variables, which is also known as independent variables. You cannot leave them. If you leave some important independent variables, your model will not be a strong, or you say, sometimes it is not fitting well. Because, what has happened, if you do not do this, you end up with a wrong model, as the model will try to assist coefficient to the variables that do exist in your data set. But there will be no values to the variables that you have, you have totally missed them out. आप कुछ प्रिडिक्ट करने की कोशिश कर रहे हैं और किसी डिपेंडेंट वेरिएबल को प्रिडिक्ट करने के लिए लेट्स से 5 इंडिपेंडेंट वेरिएबल्स लगते हैं, आप 2 लेना तो भूल ही गए. You ignored these 2, you only took 3 and you applied the regression model. Now when you apply the regression model, as Gohar was telling us, beta values तो सबकी आएंगी, तीनों की beta value आएगी, R square भी आएगा. But जब आप prediction करने जाएंगे, when you will try to predict why you did this, why do you apply regression model? One, you want to know what are the important independent variables that the company should focus while taking a decision. The other thing is you also want to predict. That's why it's a predictive model. You want to predict the dependent variable by putting the values of independent variables. So if you have missed out some of, and how do you go about it? How do you go about it? You can only find it out by reading reports. आप कोई study करें. Let's say you are doing a study where you want to know the store location, the foot traffic, the promotional discounts and store size on sales revenue of the store. You want to know that there are two big bazaars at two different locations, but one is doing very well and one is not doing good. So you're interested in knowing why this particular big bazaar, which is name has changed now. So this particular the smart bazaar is not doing good as compared to the other one. So you pick up some of the variables, like one is store location, the other one is foot traffic, the third one. And how do you pick up these things? How do you know that we have to pick up these variables? By reading the literature. So you read the literature, you understand, you read some of the very good studies and very good journals. You also read reports of various consultancies like KPMG and why, if they have done studies on sales revenue of different products, different stores, then you understand that okay, these are the independent variables I have to pick up. These are the important independent variables. If you do not do it, so whenever a researcher starts with a study, what I see is we try, and even I used to do it. I used to jump to the topic. I used to love in primary data, you gather the data. We usually do it on secondary data as finance people. So, हमारा motive होता था जल्दी से data download कर लो. Let's make an Excel sheet. Let's apply regression model. Let's go ahead and get the results. But the most important thing that we skip, guys, is that we need to understand what are the different independent variables that impact this particular dependent variable. And in order to know that, I have to read the literature. I have to read, multiple research papers and certain reports of renowned consultants. And then I'll come out with the independent variable. So no hidden or missing variables. You should try to do that. How we can do it? We can do it by reading the literature. Excuse me. Next is linearity. There's a need to have a linear relationship between the dependent variable and the independent variable. Now, what's a linear relationship? It suggests that the change in response y, which is a dependent variable due to 1 unit of change in x, is constant over the time period. Let's say I'm taking a time period. Okay, I'm taking a time period, and let's say there are multiple data points or multiple time periods. So they say that if 1 unit of a particular independent variable, let's take an example of FIIs. So FIIs and Nifty 50, let's say we take. Okay, so we are studying the impact of FII on Nifty 50. So for last, let's say we have picked up the period of 10 years. So let's say, what they want to say in case of linear relationship, that, 1 unit of change in FII is causing, let's say, 0.7 units change in Nifty 50. This should remain constant over the years. Let's say from 2015 to 2025, 10 years data, it should be constant 15, 16, 17, 18, so on throughout the period. It should not change. Then I say that there is a linear relationship between. Maybe it's 2015 figure, 2016, 18, 20. The 1 unit change in Nifty 50 should be the same with 1 unit of the independent variable FII. So you can check, it's very easy to check the linear relationship. You just make a scatter plot on any software you're working it. You can even do it on Excel. You can do it on eViews, any software. You can do it on R, and you can check whether, how is the plot. Is it something like here and here? Then you say, no, there's no linear relationship. The points are also falling. apart from the straight line. So the second important assumption is that we plot, the graph between each independent variable and the dependent variable and see that it comes out to be a straight line. This is interesting. No multicollinearity. Now, what is multicollinearity? We need to understand. The independent variables that we have taken, okay, the independent variables that we have taken should not be correlated with each other. Let's say y equals to alpha plus beta 1 x plus beta 2 x2 x1 plus beta 3 x3 so on, error term. Okay, so x1 x2 x3 and so on, they should not be highly correlated. Correlation to hoga, to a certain extent there will be a correlation, but they say that it should be low or moderate. If they are highly correlated, they're talking the same thing then. So, why they say there should be no correlation. So if they are correlated, that means there is a problem of multicollinearity. If the independent variables, let's say x1 and x3, they are highly correlated, that means there's a problem of multicollinearity. So, if they are highly correlated, they will explain the same information about the dependent variable. वो दोनों ही एक दूसरे से इतने ज़्यादा correlated है कि वो dependent variable के बारे में same ही information बोलेंगे. So the model will not be able to know which of the two variables is actually responsible for the change in the dependent variable. इसकी ये दोनों highly correlated है, इनके बीच में correlation 0.9 है. अब x1 की वजह से y में चेंज आ रहा है या x2 की वजह से y में चेंज आ रहा है, it will be difficult to tell. So let's understand with an example. Let's say the monthly sales revenue based on the advertising spending, marketing budget, and number of customer inquiries. You're doing a study, you want to know, this is your dependent variable monthly sales revenue, and these are your independent variable x1, x2 and x3. So one is advertising spending, one is marketing budget, one is number of customer inquiries. Now I see when I do the correlation, I see a very high correlation between advertising spending and the marketing budget. Obviously spending and budget go hand in hand. If this is high, that means your budget is also going high. If this is low, that means the budget is also low. So when these two are highly correlated, that means your model will not be, able to tell that the change in y is caused by this particular variable or this variable, because they are both giving the same information. This is the problem of multicollinearity that we need to remove before we, so you will find this problem when you apply regression sometime. So you have to remove the problem of multicollinearity by checking the correlation among the independent variables. Among the independent variables. So आप क्या करते हैं? What you do, you first do not take the dependent variable. आप dependent variable को नहीं use करेंगे while calculating the correlation. You people have learned how to apply correlation on eView. So what you will do is, whatever your dependent, I have shared a data set with Dr. Firdaus. So you people must be having that Excel sheet. So whatever your dependent variable is, you will only take independent variables, and among the independent variables, you will apply a group correlation. Now, once you apply the group correlation, you will be able to see which two or more variables, two variables, each independent two variables are highly correlated. Okay. Now, I will explain here also, and I'll also explain when we actually apply, we have the practical session on it right now after some time. So basically what you do, you run correlation analysis using all the independent variables given in a particular model. Now, find if there is a high correlation between two variables. So in this example I've taken, these are the screenshots of my paper. So I saw a higher correlation between x3 and x4. and the correlation was 0.953. So we say anything above 0.75, but when my scholars do it, I say it's okay if it goes till 0.8, 81, 82. You leave it, you do not consider it high. Consider anything high above 0.85. So 0.95 is a very high correlation, that is 95.36%. So there is a problem of multicollinearity between the independent variable x3 and x4. So what is the solution? We drop any one of these two variables. So the next question that you ask, ma'am, कौन सा variable drop करेंगे? x3 को drop करूँ या x4 को drop करूँ? There's a procedure for checking which one to drop. So you apply regression, proper regression, using all your independent variables and dependent variable. Once you apply the regression, अगर आपने regression apply कर लिया तो कभी भी आपने life में अगर regression के रिसर्च पेपर्स पढ़े होंगे तो आपने देखा होगा कि रिजल्ट में हर इंडिपेंडेंट वेरिएबल की p वैल्यू आती है. So there's a p-value attached to every independent variable. And we also say that if the p-value is less than 0.05, then your particular independent variable is significant. Significant means the independent variable is significantly impacting the dependent variable. Please do not worry, परेशान मत होइए. जब मैं आपको अभी लगवाऊंगी तो मैं एक एक चीज डिटेल में समझाऊंगी. I'm just explaining you how we do it. Then I'll show you how we do it. Okay, so let's say out of these two variable x3 and x4, x3 की value, p value जो आती है, the p value of x3 is more than 0.05. That means it is insignificant. So we know, और x4 की आपकी कम आती है 0.05 से, so I'll say that it is significant. So I'll pick up x4 and I'll drop x3 in the final study. So then I'll again apply regression, और उसमें which variable I'll not take? मैं x3 को नहीं लूंगी. I'll drop out x3 and I'll take x4. Why? Because my x3 was insignificant and x4 was significantly impacting the dependent variable. Okay. Now, any doubt till here? Anyone? See, robust model means something which is, a strong predictive model. Okay, predictive model means that the reason why you created a model, obviously you did a research, you applied regression, so you must be having some objective that a particular thing can be predicted by using these independent variables. Okay. So let's say I want to study GDP. So I'll check the impact of interest rates, FDI, inflation, and other things on the GDP. So if my model is strong, it is robust, that means मेरे जो error terms होंगे वो बहुत ही कम होंगे. I will have few error terms, and the other thing is my prediction will be better. 100%, so nobody can predict. Okay, even the weather forecast till now in India cannot predict whether it will rain or not on a particular day. So 100% the prediction nahi hota, especially financial data mein. But yes, if the model is robust, the prediction will be more towards the actual. So the predicted values, the predicted value and the actual value, the difference will be very small. एक आपकी predicted value है जो आपने मॉडल से निकाली, फिर जब टाइम आया तो एक एक्चुअल वैल्यू भी आई उस पर्टिकुलर वेरिएबल की, इन दोनों का जो डिफरेंस होगा that will be very small because your model is robust, your model is strong. Is it okay, Gohar? Now Bheem asked that, that's a very interesting question that Bheem has asked. He is asking कि दोनों ही x3 and x4 significant आते हैं. So let's say your x3 is also significant, that is it is less than 0.05, and x4 is also significant, it is also less than 0.05. इस केस में हम p value देखते हैं. So let's read the last line that I have written. After running the model, we see that x4 p value दोनों की आई होगी. Let's say x4 की p value आई 0.301 और x3 की value आई 0.0648. Which one is more near to 0.05? X3. What is the threshold? The threshold is 0.055% significant. तो सबको पता है 5% significant level. Usually thumb rule कहता है 5% लेते हैं. So 5% is 0.05. X3 की p value कितनी है? X3 की मेरी p value आई 0.06 और X4 की कितनी आई? This is X3 और X4 की p value कितनी आई मेरी? It comes out to be 0.3. Which one is closer to 0.05? This one is closer. So which one is a larger value? This is the larger value, 0.3. So what I do, I drop X4. So if both are significant, in this case, this is insignificant, of course. Let's say one is 0.01 and one is 0.06. Okay, one is 0.01 and one is 0.06. दोनों significant है. Beam दोनों significant है इस case में. So which one should I pick up? I'll pick up 0.011. Okay, 0.01 because it is more near to 0.05. I'll pick up 0.01 which because it is more near to 0.05. I'll show you this thing. So you don't worry about that. Is it clear now? Can I move ahead? Okay, perfect. No autocorrelation. Let's understand what is autocorrelation. You people understand correlation very well. Autocorrelation means series का खुद के पास से correlation होना. Series का खुद के पास से correlation होना. For example, let's say that a particular student is giving, CAT exam every year. He wants to land up in IIM Ahmedabad. Okay, and he is giving CAT exam every year. पहले साल score, जब उसने पहली बार दिया उसका स्कोर आया 81.6 परसेंटाइल. नेक्स्ट ईयर जब उसने दिया उसका स्कोर आया 89.2 और तीसरे साल जब दिया तो उसका स्कोर आया 94.6. ये लेट्स से मिस्टर एक्स के स्कोर है. Now they say that when the series have correlation with its history, with its past, with its lags, finance में हम कहते हैं उसके lag से, that means 2025 अभी तो रिजल्ट नहीं आया if I'm not wrong, तो उसका रिजल्ट लेट्स से फॉर एग्जांपल ये है 2024 में 89.2 है एंड 2023 में उसका 81.6 है. इसका just a second guys so that you do not get confused, just remove this. इसका इससे correlation, इसका इससे correlation, so this is this series and इसका इससे, so I take 81.6. So what I am trying to calculate, what is the correlation of the result of 2025 with 2024, its own lag. So क्या है, सीरीज एक ही है, this is x और ये क्या है x, इसको हम लिखते हैं x -1. So एक मेरी ये सीरीज है और एक मेरी ये सीरीज है, इसके बीच का कोरिलेशन, इसके बीच का कोरिलेशन. अगर और भी टर्म्स होती है, ये तो बहुत छोटा सा एग्जांपल है, तो इनके बीच का कोरिलेशन. So you are trying to find out the correlation between x and x -1. Its own lag. That is called auto. That is called ऑटो और सीरियल कोरिलेशन भी कहते हैं इसे. अपनी ही सीरीज का खुद के पास से कोरिलेशन. So they say that in case of regression model to be a robust model, there should be no correlation between the residual error terms. Residual error terms की भी एक सीरीज आती है. जब हम EViews पे लगाते हैं तो एक एरर टर्म भी कांस्टेंट, आपने देखा एक एरर टर्म भी आपका एक पर्टिकुलर ऑब्जेक्ट आता है, सो वो खोले तो उसमें इनकी वैल्यूज होती है एरर टर्म्स की। तो कह रहे एरर का उसके पास से, एरर का उसके पास से, एरर का उसके पास से कोरिलेशन नहीं होना चाहिए। व्हाट इज डिजायरेबल? Desirable is there should be no autocorrelation. There should be no autocorrelation in the residual terms. कैसे प्रिडिक्ट करते हैं वो हम बाद में सीखेंगे। No heteroscedasticity. Now let's understand this. I hope the autocorrelation term is clear. Any doubt anyone in autocorrelation? You can write on the chat box. I'll clear there itself. Okay, if there is no doubt, then we move to heteroscedastic behavior. So दो terms होती है, heteroscedastic and homoscedastic. बहुत इंपॉर्टेंट होता है ये चेक करना, सिर्फ मॉडल लगा के आर स्क्वायर की वैल्यू अच्छी आना। यस गोहर, मैं एक और एग्जांपल आपको दे देती हूँ फॉर, आई थिंक यू आर स्टिल देयर ऑन auto correlation. Okay, let's say I talk about the stock markets. Okay, so मैंने बोला कि निफ्टी 50 जो है उसकी मेरी डेली के प्राइजेस दिए हुए हैं। ओके, लेट्स से मैं पास्ट प्राइजेस लेती हूँ कोई, और मेरे पास्ट प्राइजेस आ रहे हैं कि इट वाज 20 के, 20.1 के, 20.2 के, 20 के, 20.3 के, ऐसे करके मेरी वैल्यूज आ रही हैं ऑन अ मंथली बेसिस। मैंने लिया दिसंबर 24, नवंबर 24, ओके, अक्टूबर, सितंबर, अगस्त, ऐसे करके मैं ले रही हूँ और मेरी उसकी वैल्यूज है। मैं बोल रही हूँ कि इन सीरीज ये जो वैल्यूज आ रही है, क्या इसमें ऑटो कोरिलेशन है? इस सीरीज में कोई ऑटो कोरिलेशन है? सो आई से लेट्स चेक इट इफ देयर इज एन ऑटो कोरिलेशन। तो सीरीज के अपोजिट में मुझे क्या लिखना पड़ेगा? इफ दिस इज माय N50 सीरीज, निफ्टी 50 सीरीज, एंड नेक्स्ट विल बी निफ्टी 50 -1। -1 में क्या होगा? पहली वैल्यू गायब हो जाएगी और उसके अगेंस्ट में क्या आएगी? उसके अगली पास्ट वैल्यू विच इज 20.1 की। फिर जो सेकंड वैल्यू उसके सामने क्या आएगी? दी थर्ड वैल्यू 20.2 की। जो फोर्थ वैल्यू उसके सामने आएगी, इफ दी थर्ड। सो सेम वे अब मेरी ऐसी सीरीज बन गई 20 पॉइंट, और लास्ट में कोई वैल्यू, एक टर्म जरूर बचेगी -1। you are calculating auto correlation between x and x -1, then one particular cell will be empty. अब आप इसका और इसका कोरिलेशन निकालते हो। कोरिलेशन निकालना आपको आता है, आप इन दोनों का कोरिलेशन निकालते हो, दैट इज नोन एज ऑटो कोरिलेशन। एंड इट इज वेरी इंपॉर्टेंट assumption इन रिग्रेशन कि जब आपका रिजल्ट आ जाए तो आप उसके एरर टर्म्स का ऑटो कोरिलेशन निकालो। और आपके थंब रूल ये कहता है कि देयर शुड बी नो ऑटो कोरिलेशन। डिजायरेबल क्या है कि जब आप टेस्ट लगाओ, टेस्ट में आपके आना चाहिए नो ऑटो कोरिलेशन। that makes your, they say that makes your model more strong. Is it okay, Gohar? The next is heteroscedasticity, and heteroscedasticity and homoscedastic behavior. Yeah, Fauziya is right. It means no relation with their lags. Lags means past. Okay. So hetero और homoscedastic behavior की बात करते हैं। hetero और homoscedastic में ये फर्क होता है। होमो कहता है कि आपका जो वेरिएंस है ओवर द टाइम पीरियड, दैट शुड बी कांस्टेंट, दैट इज homoscedastic. ओके, एंड hetero कहता है कि आपका जो वेरिएंस है वो कांस्टेंट नहीं आ रहा है। So the error term must have a constant variance. This phenomena is known as homoscedasticity. The presence of non-constant variance is referred to. See, variance we all understand in statistics, mean से related होता है variance. So I'm not jumping into mean and variance. Okay, the difference, I'll just say आप लोगों ने सुना है standard deviation and variance. Okay, the difference between the values of a series with its mean. और फिर आप पूरा SD निकालते हो. Okay, so that is called your variance. SD का square is variance. SD into SD. I'm not going into statistics. We don't need to go into statistics. Okay. Now, just a second. Let me erase everything. Okay. Now the thing is, somebody has written, yes ma'am, okay, he knows. Okay. Now the thing is, ये कहते हैं कि अगर layman terms में समझने की कोशिश की जाए कि why are they saying that the error term should have a constant variable. मेरा error term क्या होता है? मेरे actual values है. ओके और मेरी प्रिडिक्टिव वैल्यूज आई हैं और दोनों इन सिंपल टर्म्स ऐसे कि दोनों के बीच का जो डिफरेंस आता है दैट इज माय एरर टर्म. My actual values and my predictive values of a dependent variable. After all, why I am applying regression? I am applying regression to predict the dependent variable. तो मेरी actual values आ गई और मेरी predictive values भी आ गई. And let me tell you, predictive values past की ही निकालता है. Let's say आपने sales का, आप sales और advertisement expenditure कर रहे हो. तो ये आपका सेल्स का पास 10 इयर्स का मंथली डेटा ले रहा है, एडवर्टीजमेंट एक्सपेंडिचर का भी 10 साल का मंथली डेटा ले रहा है. तो इसके पास आपके एक्चुअल्स है 10 साल का डेटा. और आफ्टर रिग्रेशन आपने उसे बोला कि ओके भाई, दिस इज सेल्स इज माय डिपेंडेंट वेरिएबल एंड एडवर्टीजमेंट इज माय इंडिपेंडेंट वेरिएबल. इन दोनों के बीच में रिग्रेशन लगाओ. ईव्यूज ने रिग्रेशन लगा दिया, आर स्क्वायर बहुत अच्छा आया और आपकी ये वैल्यूज आ गई. आपका आर स्क्वायर आ गया. आपने कहा मैंने रिग्रेशन तो लगा दिया. अब एक्चुअल वैल्यूज तो आपने दे दी पिछले 10 साल की. बिकॉज अब रिग्रेशन लग गया तो सबकी प्रिडिक्टिव वैल्यूज भी आ गई पिछले 10 साल की. इन दोनों को जो माइनस करते हैं वो होता है एरर टर्म. एरर क्यों? अगर तो आपका मॉडल 100% रॉबस्ट है, जो रियल लाइफ में कभी नहीं होता, रिसर्च में कभी नहीं होता कि एरर टर्म ना आए. ओके अगर आपका मॉडल 100% रॉबस्ट है, जो आप मैथमेटिक्स में पढ़ते थे ना स्कूल डेज में कि LHS इक्वल्स टू RHS, व्हिच इज नॉट देयर इन द रियल रिसर्च टर्म. तो अगर ऐसा हो गया तो एरर तो 0 आना चाहिए. एक्चुअल वैल्यू और प्रेडिक्टिव वैल्यू सेम होनी चाहिए सारे ईयर्स की, 10 साल की. बट इट डज नॉट हैपन लाइक दैट. लाइफ इज नॉट सो इजी. सो देयर इज सम एरर टर्म. Now they are saying that error terms की जो values आई है भाई उसमें variance नहीं होना चाहिए. That means over the time period अगर मैं error terms को ग्राफ में बना रही हूँ तो मेरा variance high नहीं आना चाहिए. Thing like कि let's say कि मैं कोई चीज एक टनल के थ्रू डाल रही हूँ तो वो टनल ऐसा नहीं होना चाहिए. That means there is no constant thing. पहले तो फ्लो कांस्टेंट है और एकदम से फ्लो बढ़ गया और फिर फ्लो कांस्टेंट है. ये दिल्ली की सड़कों पे पाया जाता है. आप यू कैन टेक द एग्जांपल ऑफ दिल्ली ट्रैफिक. समवेयर द रोड्स आर ब्रॉडर सो सारी कार्स आ जाती. समवेयर दे गो the roads are very narrow so there are less cars here. That means in such an example there is no constant variance. Variance constant नहीं है यहाँ पे. Okay, so error term में कहते हैं कि if you want that the model has to be strong, there should be homoscedastic behavior of the error term. आपकी जो error term है वह ऐसा नहीं होना चाहिए कि कहीं तो values बहुत कम डिफरेंस में और कहीं वैल्यू बहुत ज्यादा डिफरेंस में, एक्चुअल और प्रेडिक्टिव में. Then how will you able to predict the future values? Because constant ही नहीं है error term, तो variance constant ही नहीं है उसका. That is homoscedastic and heteroscedastic. And what is desirable? Desirable is no heteroscedastic behavior. No heteroscedastic behavior. There should be homoscedastic behavior. Any doubt in this one? Okay, now we keep on, this is a very common thing, so I'll skip it very fast. Normal residuals. Normal residuals, you know the meaning of normality. आप 10 दिन से वर्कशॉप में है तो आपको नॉर्मेलिटी तो समझ आ गई होगी. ये कहते हैं कि assumption ये होता है रिग्रेशन का. The assumption says that your residuals should be normally distributed so that the prediction can be stronger. So there are tests which check the normality. जारका बीरा टेस्ट यूज किया ना आप लोगों ने. जेबी टेस्ट से आपको पता चलता है कि डेटा नॉर्मल है या नहीं. we will apply that and check if your residuals are normally distributed, it is desirable. And they say that it makes the prediction better. हिस्टोग्राम से आप नॉर्मल डिस्ट्रीब्यूशन चेक कर लेते हैं, वहां जाइपर टेस्ट की पी वैल्यू होती है, उससे भी कर लेते हैं. Okay, so these are some of the assumptions. Now, why don't we apply regression on E-views? I'm giving you 2-3 minutes. You can open your laptops, and I mean the laptops are already open. You can open the E-views. You can export. You can import the file on E-views. I'll stop sharing this, and then we'll apply this. I'll just check. I'm going to share the software now. Okay. So I'm sharing the screen, guys. I'm giving you 2 minutes to open E-views. I will request Dr. Firdaus to inform us if they have those, Excel sheets with them. This is the Excel sheet I'm talking about, guys. Do you have this Excel sheet? You can write on the message. गौहर आपको एक्सेल शीट भेजी होगी. Yes. Yes, they have the Excel sheet. Please open the Excel sheet. I'm giving you time to open the Excel sheet and open eView software. Are you comfortable importing the sheet on eViews, or should I give you the steps? I can show you here. I repeat once again, आप चाहेंगे कि मैं आपको steps दिखा दूं? Shall I show you the steps how to open the Excel sheet on eViews, or you know how to? Okay, I'll just show you. I'll just show you. So I'll go slow. People who know can please open it. People who have doubt can see the screen. So I go to File. I go to Open. I go to Foreign Data as Work File. I repeat once again for you people. I go to File. I go to Open. You can also go to Import. You can go to Open. You can go here as Foreign Data, because it's not an eView file. It's a Excel file. It's not eView's file. So you will click on Foreign Data as Work File. So you have to search your file. I'm searching my file. It's on the desktop in one of my folder. आप लोग अपने जहां भी आपने सेव किया है वो फाइल, प्लीज ओपन इट. So my file is JNK participants. So you can click on open button. So, this is the file. These are the variables you can see in the column. The first one is here. The second one is stock price, oil price, GDP. We can scroll it further. Inflation, interest rates, exchange rates, so on and on. You can go to the next button if you want to. It basically tells you what name you have given. You have already given name on Excel, so we don't need to give any name. You can just move to the next one. And, this one is showing year, and what is the data type? It is date. So it is very, we are very fortunate enough that the eViews itself reads what kind of data it is. So, what eViews has done, it has read that this particular column here has data type as dates. If I click on stock price, this is number. So we can see that the stock price that we are taking is, these are the numbers. GDP, again, you will see numbers. So for all the other figures, there are numbers. So we can simply, click on finish also. Finish. So it asks link imported series and alpha objects to external sources. The meaning of this particular question is that if we make any changes in the eViews file, the same changes you want to be happen in the Excel file. अगर आप यहाँ पे let's say आपने 1st January 2025 का figure दिया हुआ है 600, if and you change it right now while working on eViews, you change it to 700. Do you want the same change to happen in your original Excel file? See, I always suggest it should be no, because that's your master file. So, your answer should be no. Any change in this eViews file which we'll be working on should not happen in your original data file. So you click a no button to it. Has this thing opened for all, or do you want me to repeat the steps? I hope everybody has opened till now. This is a work file of eViews. This is the work file of eViews. Shall I move ahead?
Yes, ma'am.
Okay, thank you guys. Chaliye ji. So, I told you that when you open the eViews, you have a residual. So these are called objects. See, equity, FDI, exchange rates, every one variable of yours is an object. So you see, and the whole eViews is based on the regression equation. We read the book of Gujarati when we started eViews, and what he says regression is the bread and butter of eViews. So the whole eViews works on the regression equation. तभी आप देखेंगे कि जैसे आप अपनी एक्सेल शीट डालते हैं एक कांस्टेंट अपने आप आ जाता है जो अभी तो ब्लैंक होगा क्योंकि हमने रिग्रेशन रन नहीं किया है. सो यू विल सी ऑल जीरोज हियर एंड मैंने सिर्फ डबल क्लिक किया था. Rested, if you want to see rested and you double click it, you will again see zeros, NAs. That means अभी कोई value नहीं आई. And what's the reason for that? The reason is that you have not regressed it right now. You have not run regression on it. Okay. So let's not take all the variables to make it easier. And they also say that in order to run regression, you also check stationarity. So I hope that particular thing will be covered, or has already been covered in your workshop. So I'll jump to regression. So let's apply regression and let's see the results. Let's see how do we interpret the results. Okay. So what I do, I simply go to quick. I go to quick. You can do it with me. I go to estimate equation. I'll show you once again the steps. What I did, I went to quick, I clicked on quick, I clicked on estimate equation, that's the second last one, estimate equation. And I clicked on that. Now it opens a box where I need to put my dependent variable first. Let's say I want to know the, let's work on, let's say oil prices. Okay, so I want to know the impact of independent variables on oil prices. So I'll write, so first I need to write my dependent variable. So I write oil. You just need to write, one or two letters. It will automatically pop up like this. I double click on this. I give a space. I write C. C means constant. I then give a space and I write now I write the independent variable. So let's say my independent variable oil price, I say export is my one of my independent variables. So export. export, then you give a space, then let's say I also want to see the impact of GDP on oil prices. Let's say I also want to see the impact of exchange rate. Let's say I also want to see the impact of inflation. Guys, all softwares are good. So somebody has asked me, is eViews better or SPSS better? You know, even nowadays people have started working on R. So if you're comfortable in coding, you can go to R. If you are, you like tab button things, then you work on eViews or SPSS. Both are equally good. eViews is more used in econometrics data. Okay. So when you have numeric data, you can use eViews. Even the same result can be fetched from SPSS. So I won't do any ranking between eViews and SPSS. So till now, everybody is with me. I've put the dependent variable first, then a space, then constant, then again a space, then all the independent variables with space. Now, when I come to method, automatically, as I told you, regression is the bread and butter of eViews. It has picked up least square method. So the method that we were doing today, multiple linear regression, is one of the methods that is ordinary least square method. Automatically, it is picking up that. So I click on OK. Now this is my result. Let's see the result. This is the constant. These are the coefficients values that I'm getting. I'll just highlight it. These are my coefficients. I am worried about probabilities of each independent variable. I am worried about R square, and I also check the F statistics sometimes. Okay. So let's come to the independent variables. So my dependent variable you can see here is oil price. You can see here at the top. And export was my independent variable. The probability value is 0.1. Now 0.1 is more than 0.05. So what can I say? This is not a significant independent variable which is having an impact on oil price. मेरी probability value export की 0.05, that is 5% significance level से ज़्यादा आई है. So what is my null hypothesis in this case? My null hypothesis, there is no significant impact of the independent variable on dependent variable. You can write it down somewhere. So what you can say, once you apply it, see, I have shown you the steps also. Later you can use this PPT. I've sent this, share this PPT also. Go to quick, go to estimate equation, write the equation, dependent variable C. So there's a space in between. C is constant, and then space independent variable 1, then there's a space independent variable 2, then there's a space, and so on. Method by default is ordinary least square. Press OK. So self-explanatory slide is there. You won't face any problem. This is what we wrote there. And then this is the result. Let me explain you result from here. I'll explain you there also. So coefficient values and signs I need to see. If the sign is negative, that means sales will be low if salaries go high. If the salaries go high, sales will be low. Other have positive. So positive means if travel expenses increases, sales also increases. ज़्यादा अगर travel कर रहे हैं लोग बेचने के लिए तो sales बढ़ेगी. Okay, ज़्यादा market campaign कर रहे हैं तो sales बढ़ेगी. Okay, P value of independent variable, R square and F statistics. Let's check these. There is a doubt. Yeah, sure, Mohan. Sure, no problem. Let's go to eViews results. These are your eViews results. Okay, so I see the dependent variable oil price. I see export GDP, exchange rate, inflation. These variables shown here, these are my independent variables. What reading I need to see? I need to see the impact. First, I need to see the coefficients and their signs. So sign of GDP is negative with oil price. So if the GDP is high, the oil prices will be low. If the exchange rate is high, the oil prices will be low. Inflation has a positive relationship. So if the inflation is high, oil prices will be high. One thing. Second is probability. More important is you check whether which particular variable has a significant impact. So my first variable is export and the value is 0.10. Now the probability value of export is 0.10. That's what I was trying to explain you. I want to write it here. My null hypothesis is there is no significant, you can write it if you people want to, impact of independent variable on the dependent variable. Okay, so first कौन सा है हमारा export. Export की क्या value आई? P value 0.1. हम 5% significance पे ले रहे हैं. So 0.1 is greater than 0.05. So what is the criteria of null hypothesis? We all know that if it is greater, then the null hypothesis is accepted. If the p-value is greater than the significant value, p-value is greater than the significant value. आपकी p-value is 0.1 something something. Let's say 1, 2. 0.12 is greater than 0.05. That means you accept the null hypothesis, which is there is no significant impact. तो आपके export वाले में क्या हुआ? Export वाले में आपकी value 0.105, which is more than 0.05. So export is not significantly impacting oil price. Let's come to GDP. GDP की क्या value है आपकी? P value it is 0.7. So even GDP is not significantly impacting. Exchange rate is the only variable which is impacting oil price. Out of the model जिसमें मैंने 4 independent variables अभी तो haphazardly उठाए, 4 independent variables, export, GDP, exchange rate and inflation, I could see that only exchange rate जिसकी value 0.02 है, which is less than 0.05, which is less than 0.05, so it is significantly impacting the oil price. So this is the only variable. So इसी से मुझे पता चलता है that my model is a weak model. Why weak model? Out of the 4 independent variables, my 3 independent variables are insignificant in explaining oil price. They're not explaining it, properly. So this is not a strong model. Then let's come to down. Let's move ahead. Okay, let's come to R square. So so we need to understand, guys, that we are not trying to check the impact of oil price on these. Please do not confuse, Rahina. We are not trying to check the impact of oil. This is just an example to explain you how to apply regression. So let's not confuse everyone. Okay. We are trying to check whether these independent variables, exports, inflation, exchange rate, GDP, do they have an impact on oil price? Okay, and after the result, we can see that only exchange rate, and which goes, true also, that exchange rate, if there are fluctuations in exchange in the currency, we have an impact on oil price because basically we are the importers of oil. Okay, so next, so first thing I check the coefficients. I hope the coefficient thing is covered. Then we check the probability value of any regression. That also we have understood the null hypothesis. Third is we check the R square. So R square explains to what percentage the variation in the dependent variable is caused by the independent variable. The percentage change in the dependent variable, which is oil price, is caused by the independent variable that we have taken in the study. So they say 0.64, that means 64.21% change in oil price is caused by the exports, GDP, exchange rate and inflation. I repeat once again, somebody asked in the beginning also, what does R square means? R square means the percentage change in oil price due to the percentage change in exports, GDP, exchange rate and inflation. That 64% change in oil price can be explained by these four variables. Now, this is an interesting thing, adjusted R square. Now, what adjusted R square does? This is an interesting thing to know. Adjusted R square is less than R squared. Why? Adjusted R square only considers significant variables. Adjusted R square only considers significant variables. Which were the significant variables,
Ma'am?
in our study? Yes, please.
I just wanted to remind you only 5 minutes. So just requesting you to wrap up, ma'am. Yeah, just 5 minutes.
I'll do that. Thank you so much. So, Fozia is saying it means if p value is more than 5% of any variable, then that variable is insignificant. Yes. Yes, Fozia, you're right. You've understood it right. Somebody else is also written, ma'am, but the truth is that is not important, ma'am. From where I collect duration data for analysis. We'll discuss that later. Let's come back to this. Adjusted R square. Adjusted R square is 0.57. That means 57.7% change in oil price. 57.7% change in oil price is because of exchange rate. Somebody has given the right answer beautifully. 57.7% change in oil price is because of the exchange rate, because exchange rate is the only variable that is significantly impacting oil price. Okay. One more thing that you write in your results while writing a research paper or a thesis, F statistics. So in F statistics basically tell how fit the model is, at a glance. So they say that if the F statistics is the p value is less than 0.05, then your model is a good fit. If your F statistics p value is less than 5% significant, which is there in our case, okay, then they say that the model is a good fit. The model is a good fit. So if I see all the variables once again, I'll wrap it up with this. The coefficients I see are negative and positive both. So first thing that we see are the coefficients. They are negative and positive both. So impact to hoga sabka, but significant kiska aa raha hai? By seeing the probability value, I see only exchange rate as value less than 0.05. Though this is significantly impacting. Others are impacting, but insignificantly. Third thing that we check in regression is the R square and adjusted R square. More useful is adjusted R square because it tells that the variable, independent variable exchange rate, which is significant, it has a 57.7% impact on the movement of oil price. And then the F statistics that we check in order to know that whether the model is a good fit or not. So yes, we say that the model is strong because the p value is less than 0.05. It's a significant model. So guys, this is about regression from my side. If you have questions, you can ask. Shivangi, if possible, can you share the poll with them?
Sorry, ma'am. Could you repeat?
Can you share the poll with them? If it will hardly take a minute.
Ma'am.
You can ask for Dr. Firdaus.
Okay, sir, are you there? Okay, can we do that?
Just 1 second, I am sharing.
Thank you.
Kindly check the inbox. I have shared the Google form. You all are advised, to fill it within 10 minutes.
So guys, Dr. Firdaus has shared a Google form where there are a couple of questions that you can, try to attempt. It will only check whether, you guys have understood the concept of regression and basically the concept and what values you check when, you get the regression output. So kindly take 2-3 minutes and meanwhile we can have questions. Shivangi, if somebody have doubts.
Yes, ma'am, definitely. Thank you for the insightful session, ma'am. And now we open the floor for questions. And participants, please feel free to ask your queries one by one or share your thoughts with ma'am about the session. And let's make this an engaging session. So, who wants to come first, please? You can just either write in the chat box your name or you can just start by asking questions directly.
May I?
Yes, please.
Hi, ma'am. My name is Vidhu, and I'm a PhD research scholar from Ajmer University. I would just like to thank you because I've been working upon this topic for quite a long time. But the way you have explained it, no, in so much of the simplicity. Thank you so much, ma'am. Thank you.
My pleasure, Vidhu. That it was useful to you. It gives pleasure to the professor also. I
Yeah,
wish
yeah.
you all
And
the
I would
best
like
for
to
your
connect
PhD.
back later after this session also. Maybe if you can share the email ID, I would be requiring your
Yeah, definitely.
inputs for my
Definitely.
work.
Definitely. Definitely.
Yeah. Thank you. Thank you so much, ma'am.
Request for next question.
I think Shivangi, they were asking in between itself. I could, just check their doubts and I was clearing the doubts side by side.
Yes, ma'am, they
They're
were
asking,
asking. I'm
yeah,
just
yeah.
expecting if somebody wants
Yeah,
to,
definitely, definitely.
before
You are doing,
concluding, if
definitely, you're doing your job. I can totally understand that. Uh, Otherwise, I'll just request you and Dr. Firdaus to share the PPT, the Excel sheet, and that's it. The PPT and the Excel sheet with the participants, and they are also asking for the recording also. So if you can give the recording.
Definitely, ma'am, we'll share both the things. In the meanwhile, we can have, I'll just check the chats as well. Oh, somebody was asking few questions.
Sure.
And like Fatima was asking in between, error are the missed variable that hasn't been taken into study. So I don't know.
Errors are
Actually,
not the errors are the missed variables. Yes, yes, she's right. Where has she asked? Sorry, I skipped that.
ma'am, at 12:26 p.m. it was in the starting
Okay.
messages when we started
Yes,
the
the
PPT.
errors are, the errors are there because you have missed some variables. Some explanatory variables that should be there in the study have been missed by the researcher, and that's why there is an error.
One question comes from Gohar. Like the person is saying, if the beta value is 0.83, how can we interpret it?
Which value? That I did. 0.8. I took the
Okay,
example
okay.
and
And
explained. Yeah.
okay, great, ma'am. One of the person was asking about the robust model as well. I think you have explained
Yeah,
that as well.
answered.
Okay, great. And I think most of the answers you have already given. One of the
I think
person is asking,
somebody,
ma'am,
sorry.
yeah.
Yeah.
Just a quick question from one of the participant, which is better e-views or SPSS?
I answered that also.
Okay, there. I think
Yeah.
you have covered, I think, all the chats. I don't think so there is any. If still some participant wants to ask any question, I request you to ask, or else we'll close the session.
I have okay, Bheem is asking about logic model. We could not do it because, even this could have been expanded for at least 1 hour because we could not check the residuals also, Bheem. We were still doing the regression one, the multiple linear regression, but I do understand because people were doing on evenings and they were facing problem. So usually the practical sessions go a bit slow as compared to they go a bit slower than the regular classroom sessions because you're applying it, and it is useful only because when you apply it. Maybe in the next, Dr. Firdaus organize some other conference in future, and then maybe we can continue with some good new regression model. What do you say, Dr. Firdaus?
Yes, so we are, in preparation of next program. So soon we will be sharing with them. So meanwhile, there are only, 10, responses to this Google form. Now 12. So,
Okay. Maybe they can do it
uh,
later then.
yes, so we will be sharing, with you all the later results. So I think, you all need to work hard to learn what's we, discussed today and the, guidance of Professor Silky. So before we
Yeah.
end, I would request all the participants, kindly open